Okay. Celeste, the other thing you mentioned having problems with is simplifying radicals. And on a couple problems I saw that, but actually on a couple of these problems where you thought you had a simplifying radicals issue, you also just had an issue on the whole problem. So I'd like you to watch it and see where maybe most likely I'm suspecting a sign error here when you do things out. So our distance formula, we're trying to find the distance between 3, -3, and 1, 3. And so the distance formula says we take the difference in x's, 3 minus 1, and square it. Take the difference in y's, -3 minus 3, and square it. Put the square root of the whole thing. And so we have the square root of 3 minus 1 is 2 squared. -3 minus 3 is -6 squared. This is equal to the square root of 4 plus 36, or the square root of 40. Okay, so you had something that ended up different that was fundamentally not equal to the square root of 40 on this problem. So now we want to see if it can be simplified. And the type of simplification we're looking for when we don't have fractions involved is a perfect square that's a factor underneath here. So we can note that 40 can be expressed as 4 times 10. Now, it can be expressed as a lot of products. It can be expressed as 8 times 5 and 2 times 20. I know that. But the reason I picked these two is one of these is a perfect square. And so once we've got that, we realize that could just be written as square root of 4 times square root of 10, which is equal to 2 times the square root of 10. So the deal when you're breaking this down into a product of two things, pick it so that one of those things is a perfect square and one of them isn't. And then we check here, what are the factors of 10? 1, 2, 5, and 10. None of them are perfect squares, so there's no further breakdown that we can do of the square root of 10, and we're done here.